Okay, section 6. Now we're going to look at problems that involve some congruent triangles. Okay, example 10 here is asking you to prove that the angle bisector of PQR, to prove that QZ is an angle bisector of PQR. Now, what we see here is that it is a construction, something that you have already learned in Set 1. Okay, so in this construction, what you have learned is that in drawing this, you are able to form an angle bisector, but we have never asked you guys to try to prove it before. So now in Sec 3, we're going to revise what you learned in Sec 1 and how this was formed. Okay, so how do you know whether this is an angle bisector? Like mathematically, how do you prove? Don't go and measure. How do you know? Okay, first you need to know how was this even drawn in the first place. There's a bunch of words here. I'm not going to read it to you. If you want, you can read it yourself. But in this video, I'm going to show you how it is drawn. Okay, I've prepared this. So do you remember that when you draw a line with an angle bisector, you put it here and you can draw it like that. Okay, I hope you still remember this is how you got the length here. This one and this one. You cut it here, you cut it here, and then you have 2 points here, right? So according to a diagram, this is my Q, this is my X, and this is my Y. Okay, you can look at the diagram. Okay, so in other words, if I draw it like that, means that these two are the same length. Okay, so this is the first proof that we are going to use. QX is equals to QY. Alright, because that is what we have drawn. Then, second one, how do we get, do you still remember, once you get a point, how do we get this point Z over here? In order to connect from Q, I connect to Z, right? How do we get this point? Do you still remember? I hope you do. O-level, this is still tested. So this is, let me show you how you get that. Let me clear all these. Easier to see. Alright, so I'm going to use that black color or blue color. Okay, so how it's done is this. I will put my compass at this point, fix it at the length, and then I draw an arc. Then I'm going to put my compass at this point here. At the same fixed length, I'm going to draw an arc. Okay, then you will see that, hey, I'm able to draw a line that connects them. And that red color line is my angle bisector. And this point here is my point Z. And this point X, Y, and Q. Okay, sorry guys, you have to tilt your head a little bit to see this. So that is how I form my angle bisector. In other words, the distance from here to here and the distance from here to here is also equal, right? Because I use the same fixed arc to draw it. It's actually the radius that is fixed, but I draw it at different side. Okay, so you see that I have this and this also equal in length, and therefore I can prove that XZ equals to YZ. Hope you still remember the process of you forming the 3 points that I just mentioned. Okay, and then the last one, when you connect the point, QZ is equals to QZ, which you have common side. Now once you have done this, you realize that you have enough information to prove that this triangle on the left and this triangle on the right are actually congruent triangles. You can prove that XQZ and YQZ are congruent. What rule am I using here? SSS congruent test. Therefore, angle XQZ is equal to angle YQZ. and angle PQZ is equal to angle RQZ. So in that case, I have proven that it is an angle bisector. Okay? Next example is to show perpendicular bisector. Before you watch the next video, I hope you can try first. Okay, using the same logic, recall how you drew it. Remember, when you are constructing something, you are always using the radius of some arc. Okay, radius of some circles they are drawing, and then you use the arc, and that is a good hint because you can always assume that they are equal length when you're doing that. All right. Okay, thank you very much. Take some time to do example 11 before you watch the video.